This is Professor Pelton. This is part 1 of chapter 3, section 7 on inverse functions. So an inverse function just undoes whatever the original function did. So in order for it to actually be an inverse function, we need to do the composition of the functions. They should undo each other and leave you with x, essentially. So that you put f into g or g into f using the function composition. They should cancel out, leaving with the original x value. Okay. So as a result, the domain of the function is the range of the inverse, and the domain of the inverse is the range of the function. Thus, accordingly, if you have a function of f of 6, which means you're plugging in 6 of the function, and you get out negative 2, right? So if you have an inverse function, if you plug in negative 2 into the inverse, then that inverse will spit back a 6, okay? So using that concept, pause the video, do the student problem. All right, for the student problem, the inverse, you plug in negative 3, you get out 5. So thus, the original function, if you input 5, you're going to get out negative 3. Okay? All right, so that's just arbitrary functions. So let's look at a graph now. We'll call the graph g of x. So if I have a graph g of x, the inverse, I'm sorry, g of 3 is what? So g of 3, okay, so we're going to go to 3, right, and go up. So that maps back to 1, right? So we get a value of 1. So the question is, what's g inverse of 3? Okay, well now we're going the other way. So g of inverse of 3 goes to here, and it goes down to 5. Okay. Excuse me. So pause the video, try the student problem. So g of 4, right? Input 4. Okay, what are we going to get out? I don't know, something over here, 1 point something. We'll just estimate it, I guess. It doesn't really matter. So we'll say g of 4, I don't know, how about 1.8? We're just estimating. We'll just put approximate there. How's that? Okay, so the inverse going the other way, okay, so we go to 4 going this way, right? I don't know, how about 4.4? How's that sound? No, that's 5.4, excuse me, 5.4. And again, approximately, we're just estimating essentially. Okay, all right, so that's how it works graphically and then input-output wise as far as random values. For these are arbitrary functions. So how do you determine if they are actually inverses of each other? Well, again, we're going back to here, and if you do a function composition, you should get just the x back, or whatever the variable is you're using. If it's t for time, you just get time back. A for area, whatever the case may be. All right, so I'll do f of g of x, right? Which is f of g of x, either way, right? Whichever one you prefer. So I'm going to write the f function first, which is 3x plus 2, right? Because I'm using the original f function first. Then I'm going to put g inside, which is x minus 2 over 3. Okay? All right, so what happens is the 3's cancel. I'm left with x minus 2 plus 2. So this equals x, right? So basically, that is correct. So this is basically f inverse of x. So we've proved that it is actually an inverse of f. Okay, so that's what the g function is. So let's try the same thing over here. Okay, so we'll do f of g of x. Okay, so we'll write the f function minus 1. So we get x minus 1 over 4. So that's going to leave me with x minus 1 over 2 minus 1, which is x over 2 minus 1/2 minus 1, which is essentially x over 2 minus 3/2, right? So essentially, we're not left. This does not equal x. Nothing. It didn't all cancel out. So this is not the inverse of f, basically. Okay, so those are not inverses. The original one is inverses, but the second one is basically. Okay. All right, you can think of it this way also. This one is also the inverse of G. So F is the inverse of G, and G is the inverse of F. So either way you want to look at it. All right, pause the video. Try the student problems for yourself. Okay, so let's try to see if these are inverses of each other. Oops, f of g of x, sorry, wrote that wrong. So we'll write the f function, 4x minus 7. Then we'll plug in the g, which is x minus 7 over 4. Okay, well the 4's cancel, so I'm left with x minus 7, which is x minus 14. Well, that didn't cancel out. That does not equal x, right? Okay, so this is not the inverse of x. This is not the inverse of g, right? It's not. Okay, so let's go over to here, check this one. So we'll do f of g of x. So I'll write the f function, 2/3 x plus 6. And then we'll plug in the g, right? So we're going to plug in the g. So 3/2 x minus 9. So that gives me 6 over 6x minus 18 over 3 plus 6. You can probably write that a little bit better. That's kind of sloppy. Minus 9 plus 6. All right, that's better. Okay, so we get equals x minus 6 plus 6, which is equal to x. It looks like they are actually inverses of each other. So this is the inverse of x, and this is the inverse of g, right? So essentially, if you're doing software engineering, you're looking for a function that undoes the last thing that you did, even if it's multiple steps. Whether it's 1 step, 2 steps, 3 steps, or 100 steps, you want a function to undo whatever you did before. That's what an inverse function is. There's the end of part 1.